Good afternoon, guys. My name is Luis Rango.
Paul Devlin,
Max Grandy.
Greg Cohen. Our mentor group, or our mentor company rather, was Clark Nexsen. We have 3 mentors: Caleb Hurst, who couldn't be here, Eric Bowery, and Dave Parker, who we want to thank for helping us all semester. We really appreciate it. All right, our project site is located west of Powhatan Avenue, between 40th and 43rd Street in Norfolk, Virginia. It's located on the Old Dominion University campus. Some of the goals for the project were to have a 200 by 100 foot engineering research building, as well as 4 150 by 80 dormitory buildings, and to also provide on-site parking for all 5 of these buildings. We also wanted to have decorative site features such as a fountain located near the research building, as well as plenty of open space near the dormitories for students. And we also wanted to set aside at least 12% of the site total area for a stormwater management plan. The site is zoned as institutional campus district. It is about 7.48 acres and is rectangular in shape. Some of the existing conditions is a small 1-story building, softball field, soccer field, as well as some sidewalk around the site. This is a satellite image of our site. There's the 1-story building up in the corner, softball field, soccer field, sidewalk around the back. Our site was mainly flat, less than 2% slope. It also provided plenty of on-site access to stormwater connections, water main connections, as well as sanitary sewer connections. This is our first proposed layout with 2 separate parking lots. While they did provide adequate parking for the research building and dorms, we felt we could come up with a simpler design. This is the design we went forward with. It's got a combined parking lot, 55 spaces. We've got the research building over here on the northern end of the site, which is closer to campus. And we still have plenty of open space in between the dorms for students. We have two points of transportation access, as well as plenty of utility connection access. We got existing sanitary sewer running from west to east along the center of the site, water mains running across the west side of the site, as well as the north, and stormwater outfall located over here on the western portion of the site. And the site is going to be, due to the amount of stuff they've packed into smaller areas, likely to be completely developed, but there's still be a pretty good amount of green space left on the site after development.
The grading plan of our site was guided by the City of Norfolk Code of Regulations. The maximum slope used on site was 3 to 1, although most of the site was less than a 5% grade. We maintained a positive drainage away from all the building pads, which drop in 6 inches of elevation for the first 10 feet away from buildings. And we also had a quad area between all the dorm buildings and a decorative fountain adjacent to the engineering research building, which was viewable from the road to provide aesthetic appeal. The drainage ponds shown here in the dark blue outlines, they all had a side slope of 3 to 1, and they took out a total space of 0.9 acres of the site, which was 12% of our total area. For the grading of the parking lot design, which is where we started, we kept the longitudinal grade of West 43rd Street, which was on the east side of the site, which was 1.3% down. And going into the parking lot, the entrance was an uphill slope of 2%. And we did this to prevent excessively low spots in our parking lot. Then from north to south in the parking lot, it's sort of a zigzag design. And all the slopes used were 1% or negative 1%. And from east to west, it was also it was a V shape with negative 1% and 1%. And the 3 low points shown here with the elevations are the locations of the inlets in the parking lot. All right, this is another plan view of our site, and the sidewalks are shown here in purple. And all the sidewalks had a maximum longitudinal slope of 5% and a max cross-sectional grade of 2%. And all turns in sidewalk had a radius of 5 feet in accordance with ADA regulations. And around the perimeter of the parking lot, you can see in the circles is where we would have curb cuts. And on the entrance to the parking lot is where we would have a crosswalk as well. And the parking lot had 155 spaces, 6 of which were handicap spots. The only road on our site was in the northwestern corner, shown here in plan view, and the longitudinal profile as well. It's 140 feet long, and its purpose was to access the dumpster pad for the engineering research building. It's sloped 2% to the east side of the site, so the stormwater would be collected in the green inlet shown in plan view, and this would pipe it to the adjacent drainage pond. And the design speed for this road was 25 miles per hour.
So after successful completion of the grading plan, stormwater management practices were then developed for our site. To begin this process, we used the water drop test on AutoCAD. This basically simulates if you drop the water on a specific location where it would end up flowing. This allowed us to develop these following diagrams. This is the pre-development watershed areas. It consists of 9 areas, 4 of which drain off-site. And here are the post-development watershed areas. Again, 4 of which drain off-site. There are 14 total areas. From these watersheds, the longest time concentrations were calculated. It ended up being the green area for the pre-development, which totaled just over 46.5 minutes. And the lavender area for the post-development was just over 20 minutes. Here are some sample calculations, which we used Excel to calculate overland flow, shallow concentrated flow, and concentrated flow regimes. So after computing the longest time concentration, we were able to determine the rainfall intensity to use the rational method. We also found the total area for our site and a weighted C value. C values of 0.9 were used for the impervious land cover. This included building pads, parking lot, sidewalks, and C value of 0.3 was used for all other impervious land cover. The rational method ended up outputting 7.26 cubic feet per second for our pre-development peak flow, and post-development 18.89 cubic feet per second. Because there's such a disparity between these two values, then detention ponds must be used on this site. We ended up using the rational method for this. We sat down with Eric and had several long conversations, and this is what we ended up computing for a hydrograph from the calculations. With some simple calculations, we determined just over 30 acre-feet of detention pond volume would allow for the ready for the site. From here, we developed the utility layout for the stormwater. As you can see, the northern, which is on the left, and the southern zones on the right, as well as the parking lot, all go to one point of analysis. The drainage ponds were interconnected, so this would ensure that the heights remain constant between the ponds. And next, Elise will walk you through the wet utilities and EFC.
All right, so for learning module 4, we had to design a water system, and also design a sanitary sewer system. We had to determine our pipe sizing and design velocities, and we had to establish our erosion sediment control phase plan, phase 1 and 2. All right, so for our water line system, it's denoted in blue here. It is a 12-inch ductile iron pipe that starts at then we use a loop design starting at the southwest corner up to the northeast corner. And our power flow was computed to be 2,036.4 gallons per minute. For our fire hydrants, we have 2 of them, one in the quad and then one just behind the engineering research building. Every building has to be within 250-foot radius. So we found that in the City of Norfolk regulations. So, and we cannot have a fire hydrant 50 feet from any of the buildings. For a sanitary sewer, it's denoted in brown. The minimum slope we could use was 0.50% for each slope, for each pipe, to meet the requirement of 2 feet per second. Our laterals came out to be 2.1 feet per second because our site is really flat, and our mains were 2.43 feet per second. Manholes were placed in each of the turn in the sanitary sewer, and our mains were 8-inch PVC, and the laterals were 6-inch PVC.
Touch the screen.
This is shutting down.
Just give you an option to cancel that.
Our overall peak factor we used was 3, and the sanitary sewer lines, our sanitary sewer pipes serve 36 students per dorm and 100 employees in the engineering research building for a total of 244 people. So for our erosion sediment control plan phase 1, we had 2 construction entrances, one in the east one in the north entrance. We also had 2 sediment basins. One right here, right up under the construction entrance. That's for our proposed pond, and it's also low points we put one there. We also put one in the south that was suggested by our mentors, right in between our dorms, as well as a diversion dike, going from the lowest point into the sediment basin, and silt fence surrounding our project. And also we have 4 inlet protections that are going to remain there throughout the project. Finally, for our erosion sediment phase 2, we just added diversion dikes going into the new drainage ponds, outfall inlets going for protecting the outfall pipes. We added in some permanent seeding for areas that are already complete with construction, and the silt fence still remained the same. And finally, the inlet protection, we added 3 of them for all the low points in our parking lot. And finally, this is our rendering of our site. We have 3 different pictures, and we have a picture of our founder and then one of us. With that, does anybody